This is week 9 how-to video, and we are looking at number 1. The grid at the right displays the graph of a line. What is the slope? To find slope, we need to find where the line crosses the crosshairs of our graph. So for example, this point right here, the line crosses across here. At this point it does not. It does not meet there. And here's the next one. Now there's more, but this is enough for us to get slope. Slope is rise over run. So for me to get from this point to the second point on the right, I would go down 2, and I would go to the right 3. Now down is negative, and right is positive. So the slope would be negative 2/3. What is the slope of any line parallel to this line? Parallel means it is the same slope, so that when you graph them, they would not touch. And the only way for two lines to not touch is if their slopes are the same. So what is the slope of any line parallel to that line? Would be the same slope. What is the slope of a line that is perpendicular? Now perpendicular is a line, perpendicular lines cross at right angles, meaning they create a right angle when they meet. That has a special relationship. It takes the slope of one line, it flips it, so it's a reciprocal, and it takes the opposite sign. So in this case, since the slope is negative 2/3, our new slope is positive 3/2. The volume of a prism is 54x cubed y cubic units. The area of the base is 18x squared square units. Which expression represents the height of the prism? We're going to use our knowledge that volume equals area of the base times height. The volume is given to us as 54x cubed y. Area of the base is given to us as 18x squared. We are looking for height. To solve for height, we would divide both sides by what we don't want, which is the 18x squared. That would give us h isolated, because these cancel. And now we have this, which is what we do need to simplify. We have 3 x's in the numerator position and 2 x's below. So that means we can take out both of those, and it would leave 1 on the top. 18 and 54 simplify. 18 goes into 18 once, and 18 goes into 54 3 times. So we have a 3, we have 1x remaining, and the y was never touched. So which expression represents the height? C. Number 3, what is the point of intersection of the lines represented by these two equations? I'm going to solve these. You can use substitution or elimination, or you can even graph them. But when you graph them, it's pretty approximate, and you could guess wrong on your approximation. So I would recommend elimination. It's lined up already, so elimination is best used in this situation. I add them vertically. Nothing has to happen, nothing has to change, which is nice. If I add them vertically, the y's cancel, and that gives us 6x equals 9. We divide both sides by 6, and x equals 9/6, which reduces to 3/2. That is the x. So right there, G is correct. If one of the others was also 3/2, then we would have to take 3/2 and plug it into one of the original equations. I would choose the first one, so we'd get 2, and we'd plug in 3/2 for x, and solve this one for y. I chose this one because when I take 2 times 3 halves, the 2's cancel. And that gives us just 3 plus 3 halves equals 7. We subtract 3, and we get 3y equals, subtracting now, so 4. Divide both sides by 3, and y is 4/3. And that does check. Number 4, the population of a certain state is declining, and consequently the state loses electoral college votes after each U.S. census is shown as shown in the table below. Which equation represents the line of best fit for this data? Well, it's declining, so the slopes will be negative, and that is true. All of the slopes are negative. Negative 1, negative 1, 0.01, negative 0.01, negative 0.01. To do this question, I'm going to use a TI. I'm going to go to Stat. I want to edit a list, so I'm going to enter. I'm going to put 1970 in for the first one, 1980 for the next one, 1990, and 2000. I'm going to go to the next list. I'm going to put in the appropriate numbers that match up with each year. 12, 11, 10, and 9. Now to get the line of best fit, I'm going to go Stat, Calculate, so I arrow over to the Calc, and I go down to what's called LinReg, linear regression, which is another word for line of best fit. I go Enter, Enter. And this tells us that if you have y equals ax plus b, a, which is the number in front of x, is the slope, you have negative 0.1. That would give you C or D. B is the y-intercept, in this case 209. So our answer for this one would be D. Now you could use the slope formula, but because these are kind of, well, this one's pretty consistent because it's down by 1 every 10 years. So you could use the slope formula, and you would get negative 0.1, and then plug in a coordinate to get 209. Let's try that. We might as well do that. Let's go. I'm going to pick the two outside numbers. So this is x, this is y. So I'm going to choose these two coordinates, they're the furthest apart. So we have 2000, comma 9. That's one coordinate. 1970, comma 12. So difference in y's, 12 minus 9 is 3. 1970 minus 2000 is a negative 30. And that gives us negative 1/10, which is negative 0.1. Now if I use the equation y minus y1 equals m times x minus x1, I can find out the slope of the line. I know what m is. It's negative 0.1. X minus x1, well, it's x1 is, we can choose any of these points. I'm just going to use 2000. That's the x. And then y minus y1, which is 9. I'm just using this coordinate now to plug in, because all I need is 1 point to plug it in. So we have y minus 9 equals, and I distribute this to get negative 0.1x, and then that times that, which is negative, positive 200. We add 9 to both sides, and we get y equals negative 0.1x. Sorry, that's positive 200. Plus 209. Another way to get it besides your calculator, not too bad. Number 5, the common loon is the Minnesota state bird. The table below shows data about loon observations on 700 lakes in 1989. To the nearest tenth, what is the expected number of loons on a randomly chosen lake? Now, this is similar to a question we had with expected money or expected pay or winnings. So we take the probability times the award, or in this case, number of loons that you'd see. So the first one is 365, and it's out of 700 lakes, and that's times 0. This is a long one, so hang on to your seats here. 80 over 700 times 1, 131 over 700 times 2, 41 times 700 times 3. See how long this is? But it's the probability of each one. 38 over 17, or sorry, 38 over 700 times 4. I'm just taking the number of lakes over the total number of lakes, and then taking it times how many loons they'd see. And the last one, 14 out of 700 times 7 loons. That's a 7. If you multiply all those through and add them all up, you get 1.3. Trust me on that one. 1.3. So we fill it in. 1.3. And this ends week 9 how-to video.